Hello everyone. You are watching Master Mechanic Abhishek YouTube channel. Come let's start. In this video, we learn about the engine and engine terms, aim, explain construction of engine block, and different space available components placement, objectives. First we will learn material of the engine block. Second we will learn basic construction features of an engine block. Third we will learn placement of different components. See the difference between cast iron block and aluminum block. See the image and observe. Cast iron engine block. Traditionally, engine blocks have been made from cast iron due to its durability, wear resistance, and heat retention properties. Cast iron is heavier than aluminum but is relatively inexpensive and has good thermal conductivity. Aluminium. More modern engine blocks are increasingly made from aluminum alloys due to their lower weight and improved heat dissipation. Aluminum is commonly used in high-performance and modern passenger car engines. The engine block is the central structure of an internal combustion engine. It serves as the primary foundation for all major engine components, providing the housing and support for parts like cylinders, pistons, crankshaft, camshaft, and various other components. The construction and design of an engine block depend on factors such as engine type, performance requirements, and the overall design of the vehicle or machine. Below is a detailed explanation of the construction of an engine block and the placement of different components. Basic construction features of an engine block. The engine block is designed to house several critical engine components. The core design includes cylinder, deck surface, water jackets, oil passages, crankcase. Cylinder. The engine block contains the cylinders where the pistons move up and down. The number of cylinders in an engine varies, example, 4-cylinder, 6-cylinder, or 8-cylinder engines, and they are arranged in various configurations, inline, V, flat, etc. Oil passages. Channels are designed within the block to carry engine oil to critical components like the crankshaft, camshaft, and pistons. These passages help in lubricating moving parts, reducing friction and wear. Water jackets. These are channels surrounding the cylinders where coolant circulates to absorb and dissipate the heat generated by combustion. Proper cooling is essential to prevent engine overheating. Crankcase. The bottom section of the engine block, also called the crankcase, houses the crankshaft and connects to the oil sump. It's essential for holding and circulating the engine oil. Deck surface. The upper surface of the block, where the cylinder head is mounted. It must be smooth and precise to ensure a good seal between the cylinder head and the engine block. Now we see placement of different components: pistons, crankshaft, camshaft, oil pump, cylinder head, timing chain or belt, thermostat and cooling system, intake and exhaust manifolds. Pistons. Location. Pistons are housed within the engine's cylinders. Their primary function is to convert the expanding gases from combustion into mechanical energy by moving up and down within the cylinder. Connection to crankshaft. Pistons are connected to the crankshaft via connecting rods. The motion of the pistons turns the crankshaft, which ultimately drives the vehicle's wheels or other components. Crankshaft. Location. The crankshaft is housed in the lower section of the engine block within the crankcase. It runs parallel to the cylinders and is responsible for converting the linear motion of the pistons into rotary motion. Supports. The crankshaft is supported by bearings that sit in machine slots within the block, which allow it to rotate freely while maintaining a precise alignment. Camshaft. Location. The camshaft is typically placed either in the engine block, in the case of overhead valve or OHV engines, or in the cylinder head, in overhead cam or OHC engines. Function. The camshaft controls the timing of the intake and exhaust valves opening and closing, a critical function for the engine's overall performance. Oil pump. Location. The oil pump is typically located in the lower section of the engine, near the crankshaft. It draws oil from the oil pan and circulates it through the engine via oil passages in the engine block. Function. It ensures that engine components like the pistons, crankshaft, camshaft, and valves are properly lubricated. Cylinder head. Location. The cylinder head is mounted on top of the engine block, sealed with a head gasket to prevent leakage of gases and fluids. Components inside the head, valves, intake and exhaust valves are installed in the cylinder head. The intake valves allow air and fuel into the cylinders, while the exhaust valves expel combustion gases. Valve train includes components like valve lifters, push rods in OHV engines, rocker arms, and springs, all of which control the opening and closing of the valves. Camshaft. In OHC engines, in overhead cam engines, the camshaft sits within the cylinder head and is responsible for valve timing. Timing chain or belt. Location. The timing chain or belt runs between the crankshaft and camshaft to synchronize the rotation of the pistons and the valves. It is essential for maintaining the proper timing of the engine's intake and exhaust events. Thermostat and cooling system. Location. The thermostat and cooling passages are integrated into the engine block and cylinder head to regulate the engine's temperature. Function. The coolant flows through the water jackets and is managed by the thermostat, which opens and closes to maintain the engine at optimal operating temperatures. Intake and exhaust manifolds. Location. The intake manifold is usually mounted on the cylinder head and distributes the air-fuel mixture to the cylinders. The exhaust manifold is attached to the cylinder head and collects exhaust gases from the cylinders, directing them to the exhaust system. Function. The intake manifold ensures that each cylinder receives a sufficient amount of air or air-fuel mixture. The exhaust manifold routes exhaust gases away from the engine to the exhaust system. Conclusion. The engine block is a highly engineered and crucial component of an internal combustion engine. It houses and supports various components, including the cylinders, crankshaft, pistons, camshaft, and cooling and lubrication systems. The arrangement and integration of these parts depend on the engine's design, inline, V-type, or flat, and the engine's intended application, whether for passenger cars, trucks, motorcycles, or high-performance racing engines. If you want the complete PDF notes for this training module, go to the description and click the link to download the notes. Thank you for watching this video. If you like this video, please like, share, and subscribe. Thank you all.